Hey everybody, it's good to see you back. This is the last video in the series that we've been doing on the MicroHAMS Digital Conference in 2015. It's actually the first presentation of the morning in which my friend Kenny Richards, KU7M, talks about kit building. He takes us clear back into his childhood on this journey, and he will admit himself he's addicted to it. Join me now as we enter Building 37 on the Microsoft campus in Redmond, Washington.
Last night I realized something, and it's kind of one of those gut-wrenching realizations that you can really only have the night before you're going to give a talk early in the morning. And two things I kind of realized. One, I've been doing this conference for 8 years now, and I made a rule after the first one that I absolutely wouldn't be both the ringleader and a presenter because it just doesn't work. There are too many things going on, and I don't ever have a real chance to prepare my talk very well. So I violated that rule today, so I apologize up front. Things will probably be a little bit rougher than they should be. But the reason I did is that there's a topic that I believe very strongly that needs to be talked about some more, and people need to be encouraged some more about it. So I wanted to talk about building kits, and a lot of the kits that I've been interested in and I've been playing with are all digital, so it applies directly to kind of this topic. So that's rule number one you shouldn't really ever break, is don't try to give a talk during a conference that you actually are running. Leads me to my second thing, and this is kind of a part public service announcement, as it were. There's a lot of people that basically feel that building kits is a problem or difficult for them, and I'm going to spend some time today to kind of dispel that, because I think anybody can build these. There are kits to get you started, and as you progress, you learn the skills you need, and the skills are not really that difficult. But the second realization I had last night, this really kind of concerned me, is that I might be preaching to the choir, as it were. So just real quickly, how many people have actually built a radio kit before in the room? Finishing is not a requirement as long as you started it. So not quite everybody, which is exactly what I was afraid of. So there'll be a few things here which I'll try to make you laugh, but are probably not going to be terribly interesting. I don't need to convince you of something that really already happens. So yes, this is the original old man. I've been a ham now for more than a quarter century, and I was very lucky to be elmered by hams that actually started their ham career, as it were, in the 1930s and 40s, which is literally 2 generations ago, and things were different then. So a lot of my stories and learnings that I got from a different era, they basically taught me that I could do anything. I just needed to try. I shouldn't be afraid to take something apart. I could probably fix it if I really, really tried hard enough. It's just kind of the mentality that I was taught. And I was very early on, just go, try, do. The thing that I've realized recently, that a lot of people look back on those times, because that generation of hams all built everything, because you couldn't really go buy stuff off the shelf. You had to build it if you wanted to get on ham radio. But we all think that they all must be these brilliant double E's that were designing their circuits from scratch, and that's really not the case. They had what were kits back then to work from as well. They had really detailed articles and things like QST that showed them how to lay something out. They even told them where to go get the parts, which obviously were mostly scavenged, but they still had the sources, as it were, to how you get things, to put things together. So while they were building their stuff, they weren't really all double E's and doing exotic design things like that. The big thing that they didn't have is places like Mouser or Adafruit, which makes things a lot easier for us today, when we can just go mail order, all the parts that we need, and they show up in a couple of days. So that's kind of really the difference between that generation and us. So, which leads me to my second point. And yes, that is me. Yes, that hair is black and not gray. And yes, those are the same brown shoes that I'm wearing today, which I just realized. This is me in the 1987, I think, and that's the 147.20 repeater. It was located just outside of Lebanon, Oregon, where I grew up. And this picture was taken on kind of a very interesting day. I'd gotten invited to go up to the site to help doing some maintenance. I didn't know exactly what I was going to be doing, but it's like, that sounds like fun. I want to go do that. We got up there, and K7 Ian W., Von Sweet, the repeater owner, he shuts the machine down, he pulls the power supply out, he puts it on the bench, and he sits me down and says, okay, there's a pile of filter caps. Replace all the ones in there. There's your soldering gun. Go. And then he wanders off. Okay. I didn't have a double E degree. I didn't even have a high school diploma at that point. But I could go do it, right? Soldering wasn't, so I taught myself how to solder. I had people there to ask questions, and I basically took things out, went, okay, that's that size, here's a new one, and I put it back in the same place. And I just went and I did it. And that concept of just trying, just doing, is something that I think everybody needs to kind of learn and instill, that it's okay. I mean, if a crazy kid can go start working on, which I have no idea what that would have costed at that time. It had to have been thousands of dollars worth of repeater equipment. Anybody can go do these kind of things. They're just, it's doable, it's accessible, you just kind of have to try. So, a couple of things I want to dispel for those of you that haven't built a kit yet. It doesn't take a lot of expensive equipment. It really, really, really doesn't. You can go on Amazon and buy the basic essentials for less than it costs for you to come here today. The stuff you get is way better than I ever had getting started. I remember the day in college when I found a used Fluke multimeter in a secondhand store, and I thought, oh, this is like the magical moment. It's real test gear, and not the hand-me-down multimeters and things like that that I was using before that. So this stuff today is just light years ahead, and it's very accessible, very easy. It doesn't cost a lot to get started. I do have to warn you though, it's a bad habit as well. Pretty soon, you know, the multimeter turns into an oscilloscope, which turns into a spectrum analyzer, and then, you know, it's kind of a game over situation, but it's not that expensive to get started. The second thing I want to kind of dispel for those, everybody that's here's done this probably realizes that you don't save money by building stuff. That's not what the purpose of building kits is. So don't think that you're gonna go into this and save money. I know that's very counterintuitive for hams, that we're supposed to be very cheap, but that's really not what it's about. The building kits is about the learning experience. Every time you build something, you will learn something. You may not fully understand how it all works, but every time you take a step closer. And there's just a huge satisfaction that comes from putting something on the air that you've actually built yourself. It's just a magic moment that when you power it up and the magic smoke doesn't come out. The last thing that I hear from people that say that they don't try to build stuff is that soldering is too difficult. So I don't know how to solder. Soldering is not tough. Soldering is actually really, really, really simple. I taught myself how to solder with one of those wood etching iron things. I didn't, so yeah, not someone else. It's really not that hard to do. It takes you about 5 minutes to get the basic idea, and about 15 minutes of putting wires together, and you basically have it. When you get around to doing surface mount and things like that, it becomes a little trickier, but it's not hard to learn how to solder. And the other great thing that we have today that we didn't have 20 years ago is we have this place called YouTube, and people love making videos about stuff. So you just search for something like soldering, and if you don't like the first video, go to the second or third, and you'll figure it out. It's not that difficult. It's something anybody can do. So where to start? First recommendation, if you've never really built anything before, is go find a very simple, basic kit. Very few parts. The board has lots of room on it, so you can learn basically how to follow directions and map that into the physical world. There are two great places that I like. Adafruit is a place out of New York, which I actually have to read this quote directly because it's just absolutely hysterical. So Adafruit, their tagline is, we're a tutorial company with a gift shop at the end of the ride, which basically means they put out tons of videos and instructional help material about building electronic stuff. And then after you get hooked on the idea of it, they basically provide, and then here's all the kits to order everything you need to do. And they do have just phenomenal kits, really, really good instructions. And they have a whole range of things. So very simple things, a lot more complicated. They have a lot of things that tie to Arduinos and Pis and the BeagleBones and all the other little embedded computers as well. So there's lots of options for people. That's a great place to start. The other kind of classic one is Ramsey Electronics, which has been around forever. They have a lot of basic kits as well. I mean, like, you can go build a 2-meter receiver, and there's like a dozen parts in it and things like that. So that's another great place to start. And that's really what you want to do, is you want to build something the first time that's very simple so that you can kind of get a handle on it and you have that success. And if the worst case is that you destroy it, it's not a big deal. You get it again and start over again. So that's the first thing. So where do you go next? Once you've kind of built the first kit, get on Google, get on wherever, and start looking at some of these multiple places that sell kits and find something that's interesting for you. I'm going to talk about some of the things that I've built, that I've found that are really interesting, that are all kind of very digital related. The other thing that I guess I want to kind of push an opinion on everybody is that ham radio is about transmitting signals. That's kind of what makes us different from a lot of the other builders. So building your own transmitter should be like almost a rite of passage. Everybody should at least once build a transmitter that actually puts a signal out in the air. It's just really satisfying and something that's really, really easy to do. And I'm going to show you some options about that. This is kind of the board or the kit that was the genesis for this whole talk. W5OLF has had 4 versions of this board, I think now. He has a 30-meter, 20-meter, and a 10-meter monoband beacon for Whisper. Whisper do people know what Whisper is? Weak signal propagation reporting. It's Dr. Joe Taylor, the Nobel Prize, came up with WSJT, which I think he originally did for EME. He's a big EME person, allows people to do EME that with a lot less antenna and power than normal. And people have taken this digital modulation and reused it in a bunch of different ways, including this weak signal propagation reporting. And the idea is you have 2 halves to it. You have people that put signals out on the air in this format, and the signal includes your call sign, grid square, and power output, I think. And then you have a bunch of receiving stations that are all over the world, and the receiving station says, oh, I heard KU7M in CN87, and he's putting out a 0.5 watt. And it sticks all that information up on the internet. And you can go to the website and say, oh, look, my signal got to here. My signal got to there. So W5OLF came up with a really simple board to basically puts out this beacon. And it doesn't require a computer. It just requires 12 volts and an antenna. The smarts of it is all programmed into a PIC processor. And you actually give him your call sign output in grid square, and he programs it for you before he ships it to you. And I think he'll actually reprogram it if you move. So if it's a big deal, you can send him back and he'll reprogram it. This is a great kit to start with because it satisfies several of Kenny's requirements. One, it's a transmitter. So that's very important. It is very much digital, as you are sending out a digital signal. And the other great thing is that it's almost all through-hole parts, which just means it's really, really great for a beginner. There's only a single surface mount part, but it's a really big surface mount part. So even those of us over 40 that can't see anything can still attach this relatively easily. There's only a couple toroids you need to wind, which is another thing that people always complain about, that they're not really hard to do. You just follow the directions. Anyway, this is a great kit. I have one of these if someone wants to look at it. And actually, I'll kind of stop here. The MicroHAMS has been talking about having a kit building afternoon. We're going to take over the maker shop, lab, whatever it's called, here on the campus. Take it over for a Saturday afternoon. And I'm going to probably order about 20 of these. I think we can have about 20 people and build this. Because I know I built mine in about an hour and a half. So I'm assuming someone that's never done it before can probably do it in 2 or 3 hours without a lot of help. And then, dummy loads and power supplies, and we'll get them on the air. The other neat thing about this, and the kind of the other comment that I've heard a lot of times from people is that, you know, I can't build HF stuff because I don't have any place to put an antenna. You can buy 10-meter versions of this. And a 10-meter dipole is about that tall, right? So if you can't hang it out a window of your apartment, which is something I've done before, you can hang the antenna from the ceiling in your shack, and you will get out and you will have people hear you. It's kind of amazing like that. So this is really available to just about anybody. So that's one option. That's a great first place to start. The next board I want to talk about is an upgrade of the W500F one. This is called the Ultimate 3S. It is a lot smarter. It has an LCD display on it, so it actually tells you what's going on. The other board, basically, you plug it in and it starts transmitting, and there's not a lot of idea of what's happening unless you have some test gear to monitor it. This one actually tells you what's going on. Besides WSPR, it also supports QRSS, which is a really, really slow CW signal. And then some of the other ones, which I'm not even very familiar with. It can also take GPS inputs, so you can move it around. And it has, I think it actually will put out more power. This is a multi-layer board as well, meaning that it uses header pins so you build 2 or 3 boards and you stick them together. The other neat thing about this is that there are programmable LOs, which means that you can actually change the band that it uses by just plugging in a different LO. I've only built one with a single LO, but I'm assuming you can switch it. Bud, have you actually moved it across different bands?
It's the low-pass filters that you change.
Oh, I thought it was just the LO.
LO goes, it's like from 0 to 28
Okay.
megahertz.
So 10 meters then. So Bud, WB7, I want to say FUS, FHC is our local internet ham radio star. I don't know if anybody watched some of his videos. He has a great 4-part video series, I think, 3-part, where he's actually built this kit and shows you how it goes together and everything. So highly, highly recommend that. Don't worry about that. I have a link, and I'll put all the slides up so you can get where his videos are at. So that's a great next step up for the more advanced. I had to include this one because it's kind of a classic. The Softrocks have been around since 2005, I think. These are 1-watt transceivers, SDR radios. Basically, you plug them into your laptop sound card. They have different ones that have multiple sets of frequencies. So you can buy like a 10, 15, and 20, or a 40 and 80, or different variations thereof. These are a great place to get started if you're interested in SDR as well. They're a little bit more advanced kit. There's a lot more surface mount on this than some of the other stuff. I wouldn't do this as your first thing, maybe your second or third one, but this is a great digital kit to get started with, and it has all sorts of uses. I've seen people turn this into pan adapters, so they can see a wide swath of a band at one time for hunting for signals and things like that. All sorts of things it can be used for, and I think there's been multiple manufacturers of the kit. Who's built one of these? I have. You have 3 of them. Wow. And Miguel's also bought one. So Miguel, do you use yours on your remote station?
Yes.
Still?
Yes.
Okay. Miguel has a belief that you shouldn't be in the same room as your radios. He only operates remotely. So these kind of things work really well for him because everything can run through the computer, so it's easy for him to operate from someplace else. In the graduating levels of kit building, you have to talk about the K2. Elecraft brought this out over a decade ago, and it is really, really a great radio to build. This is not one that you'll put together in a weekend unless you're really, really good and don't sleep a lot. I think it took me a couple of weeks working on it an hour or 2 a night to put a basic kit together. But this, the K2 has filled the role that the Heathkits stuff did in the 60s and 70s. It is complete radio that anybody can build. basically has, as you construct it, you build the test gear that you need to align it as well. It has a huge, huge community of people to help you. Basically, if you have a problem, someone else has had the problem as well, and they'll tell you how to get yourself unstuck from it. The only, probably the thing I'd say is a problem with it is that it has the option issue where you start with the basic 10 meter to 160 CW transceiver, and then you need to start adding things, and the adding things can get kind of out of hand. So you add the SSB board to begin with because that, pretty much everybody will want that, and then you got to add, in my case, the computer control board so I can change the frequency and everything from my PC. And then you want to add the 100-watt amplifier into it, and then there's the automatic antenna tuner, and the list goes on and on and on. But this is a phenomenal radio, and it's literally a complete transceiver and works really well. Every bit as good as the $1,500 radios you get from Kenwood or ICOM. And you would have built it yourself. And it's just a really, really great experience. How many people built K2s? Wow, not as many. Anybody built more than one? Okay. All right, I was going to say, there are actually people that get addicted to it, and they do end up building lots of them. That was kind of the gist of what I wanted to talk about as far as kit buildings. Have I incentivized any of the rest of you that haven't done it? Yes. Did you have a question?
Yeah, I had a comment. So we've got on our display out here, it's a Tech Relic 506. And it comes as a radio that will, when you turn it on, when you start on 7.03, that's all that's on it. And then from there on, you put all of the ads that you want on the radio after you see what's going on inside of the radio. So.
Yeah, and the ARRL has a bunch of basic kits as well. So I know, like for the Scout program, they have a kit for CW. Basically, you can send CW with it, so you can practice with it. And they have a couple of other basic kits that they sell for these types of things. But the thing is that these places that put these, there's a lot of people that produce kits now. And you can find a kit for virtually any skill level that covers a wide range of interests as well. Most of the stuff I talked about is all have a very much a digital bit to it, because that's kind of my interest, but there are lots of other things you can do with them as well. I know I've seen kits for making pies do interesting things. The Adreno, as a matter of fact, Bud has Morse Adreno. He wanted to learn how to program the Adreno, and he thought, well, I'll try to build something that will decode CW. And over the course of a year and a half, maybe more, it has gone through multiple revisions, and it's gotten better and better and better. So it now has a display that shows you exactly what it's receiving, and he has buttons and pre-coded responses, so you can just press the buttons on it, and the whole thing is done by an Adreno. I know he's done multiple prototypes, and I know people have taken his board design and produced their own boards, and I think he's getting close to probably doing a full kit himself. And you can plug it into any radio, and it'll sit there and decode CW for you, and it works really well. So Jeremy, you had a comment. I'll get to you in just a second, sir.
I was just going to mention that SparkFun is another
place
for eating kits, especially for kids. I had some of her kids building watch kits and things like that they had a fun time doing. So they have a lot of more kid-oriented kits if you're looking for that, but they're more generic. And then if you're looking for ham kits, Hendrix kits.
Thank you. That's another good one. Hendrix kits and SparkFun.
Ham radio specific things.
Yeah. There are dozens and dozens of ham radio only type of kits out there. You'll have it can get very expensive, so you don't have actually enough time to build all of them, which is kind of the case that I am in case it. The other day, I actually discovered a kit that I bought and stuck on a shelf and didn't realize that I hadn't built it. I was like, oh, that looks like fun. Maybe I'll do that this weekend. Sir, did you have a question in the back or comment?
Question and also a comment. By the way, kit building is a great way to get your kids and grandchildren especially interested. For those of us younger guys who have grandchildren here, interested in electronics, ham radio, and kit building and things like that. So K2 versus K3, because K3 they say it's a kit but no solder. What's the difference between those two, if anyone knows?
So I built both. So a K2 is very much like the Heathkit of old, meaning that you have a board and lots of bags of parts and a huge instruction manual, and you just go. And everything, you have to place everything on every board yourself. The K3 is a bit more like assembling a PC, meaning that it gives you pre-built components that you assemble in the structure and plug in, but there's no real soldering involved. It's very much like, here's a PC motherboard, screw it down. Here's a video card, plug it in. Here's a power supply, I plug it in. It's that kind of kit. The performance of the K3 is more, but it's also a lot more expensive. And I think that's part of the reason why it's not really something you'd solder. It's because it's a lot of surface mount and just it's a lot more integrated device. But it was fun building that one too. It's even more expensive in the option category. There's a lot more expensive and cool options for it. So they're both great ones. And Elecraft has a monoband device too that I think you assemble, but I've not built that one before, the K1. Kurt, have you? You have a bigger addiction than I do, I know that. Okay. Any other comments or questions?
The K1 actually is 2 bands or optionally 4 bands.
Okay, so 6 bands on a K1. I didn't actually realize it was that versatile. Okay, so there's some assemble required then as you band switch then. So sort of like replacing your crystals. There was another question over here, and Bud wants to comment.
Yeah, I just wanted to say that's cool that you guys are thinking about having that kit building session. The Mount Baker Amateur Radio Club just finished our first kit building session. Our last session was Wednesday. It was a 2-night affair. We used the makerspace in Bellingham called the Foundry. They had a whole bunch of soldering stations. And our goal was to bring people in who have had experience building kits, knew how to solder, and people who had never done it before.
Yeah.
And put them
pair
together
them
side by side, and we built the John Hansen's TNC Pi.
Yeah,
and
actually that's a great thing.
It was a great project. Everybody had fun. People learned stuff. It was a good time.
There's a lot of packet kits now. Plug the ones in the Pi, plug them in the BeagleBone. There's I think at least 2 or 3 different ones. Did you have a comment? Okay. So anything else on kits? Okay, I just wanted to take a couple minutes. All right.
Just a quick comment for those that are interested in the vintage radio. People that have put together parts bags, basically, where you can go and strip out an old Heathkit and rebuild it, and it's kind of a lot of fun.
Oh, I didn't know that. Do they like have tube replacement, or you put solid state in place for the tubes?
Well, you're putting just resistors and inserts.
Okay. Refurb that, yeah. Yes, electrolytics. See, my first rig was actually a Heathkit, and so was my second, so I have a lot of experience in rebuilding.
Actually, there's a group, I'm not sure where they're located, but that is starting up the old Heathkit line.
There's been a group doing that for probably 10 years. I'm not going to hold my breath anymore about that happening. So I wanted to just give a plug for an organization that I'm trying to kick off with the help of some others in the room. Does everybody know what the IETF is? The Internet Engineering Task Force. So basically the group that defines the standards for how stuff talks over the internet is, it's not even a nonprofit group. It's a group of individuals that care about making standards and work for companies that are involved in it. And they put together things like HTTP/2, which is the new web browsing protocol that just got standardized. They're the ones that do things like TLS, which is the secure transmission of web content. They have lots of different standards that they put together. It's a unique organization in the sense that it's not a company-sponsored thing. You don't buy into it. You contribute to it, and all the content then becomes available for everybody. And it is held together because people have realized that in order to make things like the internet work, they need to agree on how to talk to each other. And if you think about it, that's very similar to ham radio. But we don't really have any central place that holds standards together. So Brian Hoyer in a K7 UDR had this idea, and he said, Kenny, you should make this happen. So I've been trying to slowly get it off the ground. I haven't done a great job so far, but it's getting a little closer. But we want to have the amateur radio engineering task force, as it were, and put together standards that hams come up with. There's a lot of areas that this could be used in. I think authentication is one of the ones we've talked about as being needed right away. There are lots of digital voice standards that can be used this and leverage it. There are certainly modulations that we want to start having. The other thing that I want to also happen is that I'd like it to become a repository for things that already exist. As an example, although I don't think this is probably ever going to happen, the APRS standard could get published through this organization, so that if someone wanted to go look it up, they didn't need to try to go to Bob's website and dig down through layers and layers and layers and try to figure out how APRS is supposed to actually work. So it's the organization is a very small start. We have a blog that has a couple posts, and I'm very, very close to having form software up and start having discussions. And the idea is that people that are interested, that are motivated, will have electronic place that we come and talk about things, and we'll iterate through defining these different standards, open them up, make them available for public comment, and then essentially ratify them by actually building stuff that uses them. Is there any questions about this? Is anybody interested? Anybody want to help me? Because I need a lot of help with it. We'll need people that can help write standards. We need people that can edit standards. And we need just people that can evangelize these things. So there's different places for it. That is kind of all that I had.